Chemical equilibrium and acids bases. Forward reaction, the reaction in which the reactants convert into products called forward reaction. Reactants convert into products. Backward reaction ante the reaction in which the products converts into reactants is called backward reaction. Equilibrium, the rate of the forward reaction is equal to the rate of the backward reaction in reversible reaction is called equilibrium reaction. It denotes by W arrow. Calcium carbonate equilibrate with calcium oxide plus CO2. Characteristics of chemical equilibrium. The both forward and backward reaction continuously takes place. The rate of forward the reaction is equal to the rate of the backward reaction. The properties such as pressure, concentration, density, color, etc. remain unchanged with the time. Addition of catalyst does not affect of the position of equilibrium, but in presence of catalyst, the equilibrium established quickly. Equilibrium in physical process. Solids convert into liquid, liquid equilibrate gases, solids equilibrate gases. I2 solid convert into gases. Sublimation reaction. This is the gases in liquids. The molecule into the gaseous state dissolved in the liquid under the pressure. CO2 convert into CO2 gas into the solution. The equilibrium is governed by the Henry's law. Henry's law. The mass of a gas dissolved in a given mass of a solvent is directly proportional to the pressure of a gas. The above solvent W is directly proportional to pressure. W equal to Kh into P. Kh equal to Henry constant weight by P. So the where W Kh equal to Henry's constant. As soon as the bottle opened, the sum of the dissolved CO2 gas escaped to reaches to an equilibrium concentration. The equilibrium is possible in a closed system in a given temperature. Dynamic equilibrium. Even at the equilibrium state, reaction do not stop the both. The equilibrium concentration of the reactants and products remains unchanged with the time. Here we take the graph time and concentration. Product concentration increases, reactants concentration decreases here. The time. Law of equilibrium. At a given temperature, the reactants of the molar concentration of the product to the molar concentration of the reactions. Equilibrium constant Kc at in terms of molar concentration. Small a capital A plus small b capital B. Equilibrium is small c capital C plus small d capital D. So equilibrium at constant in terms of molar concentration Kc equal to concentration product concentrations by reactants concentration. Law of mass action. At the given temperature, the rate of the chemical reaction is directly proportional to the product of active mass of the reactant. Active mass is taken as the molar concentration for the solution reaction at low concentration for the gas reaction at low pressure. Molar concentration is indicated by the square bracket. Equilibrium constant Kc and Kp. The rate of the product of equilibrium concentration of the product to the product of equilibrium concentration of the reactants. Kc equal to product of equilibrium concentration of product of equilibrium concentration of reactants, where Kc equal to equilibrium constant in terms of molar concentration. Kp equal to product of products by product of reactants, where Kp equal to equilibrium constant of in terms of partial pressure. Methods of writing the Kc and Kp values. How the Kc and Kp values following the equilibrium reactions. Here product concentration by product concentration. Kp equal to, so like this, write on Pc by Pd by product pressure, partial pressure, reactants pressure. Given reaction, directly we take the ammonia. Product concentration by reactant concentration. Kp Kc ఆ విధంగా రాస్తున్నాను చూడండి. సో H2I2 homogeneous equilibrium, the equilibrium reaction in which the reactants and products are in the same physical state is called homogeneous equilibrium. N2 gas, H2 gas, product also gas. Heterogeneous equilibrium, the equilibrium reaction in which all reactants and products are different physical states is called heterogeneous equilibrium. Calcium carbonate equilibrium with calcium oxide and CO2, solid gases. If the reactants products are in solid state, no effect concentration and pressure, the value is taken as 1. Find the Kp values of following reaction. Here Kc equal to 1 into concentration of gas, solid concentration 1 taken. Kp equal to same carbon dioxide with graphite. Barium oxide, yeah, examples given, concentrated. Relation between Kc and Kp is the relation between Kc and Kp values denoted by the following equations. Kp equal to Kc RT del power of delta n, where R equal to gas constant, T equal to temperature, delta n equal to the number of moles of product gas in gaseous states minus the number of moles of reactants in gaseous state. Case 1 delta n is equal to negative. Kp equal to Kc RT power of minus 1. So Kp is less than Kc. Positive, Kp is greater than Kc. Delta n equal to 0. Kp is equal to Kc. Here delta n equal to 2. How to take here? The moles of products in gaseous state. Here ammonia how many moles and take already 2 moles. ఇక్కడ ప్రొడక్ట్స్ అంటే ప్రొడక్ట్స్ మోల్స్ అంటే ఇక్కడ నైట్రోజన్ ఏం లేదు కాబట్టి ఒకటి తీసుకున్నాను 3 1 3 సో 2 minus 4 ఆ విధంగా తీసుకుంటే మీకు ఏంటంటే PCl5 పైన ఈక్విలిబ్రియం పైన మనకు ఒక రియాక్షన్ చేయడం జరిగింది చూడండి. The equilibrium constant is applicable only when the concentration of the products and reactants attain the concentration value. It depends upon the temperature of a reaction. It is independent of the catalyst. Predicting the direction of the reaction and calculate the equilibrium concentration. Predicting the extension of the reaction on the basis of magnitude. Higher the value of equilibrium constant indicate that the forward reaction is more favorable. The low value of equilibrium constant indicate the backward reaction is favorable, more favorable. Factor affecting the equilibrium constant. The effect of concentration, pressure, temperature on a reversible reaction by explaining the Le Chatelier principle. If a chemical reaction, Le Chatelier principle, very important. If a chemical reaction at equilibrium is subjected to change in a concentration, pressure, and temperature, the equilibrium position shift in the direction in which the change is reduced or nullified. Le Chatelier principle is applicable for the both chemical and physical equilibrium. Factor affecting the position, effect of concentration, increasing the concentration of the reactants, decreasing the concentration of the products. Favor forward reaction. Finally, the equilibrium shift in the right direction. Effect of pressure. If the pressure is increases, forward reaction is the direction is of decreasing the number of moles. Effect of temperature. The high temperature is always favorable for the endothermic reaction. At low temperature, always favorable for the exothermic reaction. Catalyst. A catalyst increases the rate of the reaction. Rate of the reaction, forward or backward reaction. Applications of Le Chatelier principle. Industrial synthesis of ammonia by the Haber process. Nitrogen and nitrogen combine to form the ammonia. The reaction is reversible and exothermic. N2 plus 3H2 equilibrate with iron by molybdenum from the delta H equal to minus 92 kilojoules. Here equation carefully observe. Effect of concentration. Increasing the concentration of reactants N2 H2 or decreasing the concentration of the products favor the forward reaction and high yield of ammonia is formed. Effect of pressure. Here delta H is equal to 92. The number of moles of reactants for the number of moles of products is the 2. So 4 to 2. So decreasing. The formation of ammonia is combined with decreasing the number of moles. So high pressure is favorable for the high yield of ammonia. Hence pressure is 200 to 300 atmosphere is used. Effect of temperature. Delta H is equal to minus 92 kilojoules. Formation of ammonia is exothermic reaction is the low temperature is favorable for the high yield of ammonia, but low temperature the reaction between the nitrogen and very slow. So therefore the optimum temperature is 725 kelvins to 775 kelvins is used. Effect of catalyst. Iron is used as a catalyst. Molybdenum used as a promoter. Optimum condition: high concentration N2H2, high pressure 200 to 300 atmosphere, low temperature 725 kelvins to 775 kelvins. Iron is used catalyst. Molybdenum is a promoter. Industrial synthesis of sulfur trioxide. 2SO2, O2, vanadium pentoxide in presence to form the 2SO3 delta is equal to minus 189 kilojoules. Effect of concentration. Effect of concentration. Here look here. Effect of pressure. Effect of temperature is there.